Hey guys, my name is Trevor Sullivan. I am a solutions architect with Stratus. Stratus is an AWS consulting partner, and we do a lot of interesting projects around the AWS cloud, including things like cost optimization or modernization of applications using things like serverless frameworks and containerization. And we also do migrations, right? We take applications and other workloads and we migrate them up to the AWS cloud and help you to monitor and observe those applications to ensure that they're operating at the best health. So feel free to reach out to us if you're interested in any services that we provide. Head over to the stratusgrid.com website and click on this Let's Talk button, and then you can just fill out this little form on the right-hand side and get in touch with our sales team, which includes myself on the technical solutions architect side. Now, this particular video, I wanted to focus on an AWS service. It's part of the managed machine learning services in the AWS portfolio here, but it's called Amazon Lookout for Vision. Now, that's kind of a mouthful, but essentially what this is it's a managed service that allows us to take a foundational computer vision model and we can tweak or do what's called training. We can train this model on our own custom data set that we gather ourselves. And then we can do what's known as anomaly detection, where we look at an image and we determine if that represents an anomaly or a normal object, right? So the simple demonstration that I have right here for quality assurance in manufacturing is basically just a couple of boxes, right? So I have two different boxes. One of these boxes represents anomalies, and we have a couple of different types of anomalies. You can see that up at the top, we've got some scratches, and also down here, we've got some puncture wounds inside of this box. But then right here, I've actually got what a normal or kind of good looking box looks like. So we have the two sides of our classification. We can classify an image as having an anomaly, which could be a puncture or a scratch, or we could just have a normal box that is healthy and properly manufactured and has not experienced any damage. So what we're going to be doing is actually starting with the fundamentals, which is gathering your data. And this is something that I've noticed is often overlooked in a lot of other machine learning videos. Oftentimes, those other videos will assume that you have a pre-existing data set. They won't really talk about how to go about gathering that data. And remember that when you're training a machine learning model, your machine learning model is only going to be as good as the data that you're feeding into that model. So we want to make sure that we are not only capturing good quality data, but the other thing you have to think about is that every single use case that somebody has for computer vision, such as using this Lookout for Vision service, is going to have a different type of anomaly that they're detecting. Maybe you are manufacturing something like aluminum cans, as this LaCroix water here is using, and maybe you want to detect punctures or scratches or perhaps mislabeling during the label printing process for those cans, right? That's another use case. Maybe you're doing vehicle manufacturing and you want to detect scratches or dents in the body of a vehicle. There's all sorts of different use cases here. And so by having these boxes right here, this is representing a specific use case that the model in Lookout for Vision has not been pre-trained on. So we're going to gather our data, organize that data into the proper structure, which we're going to talk about, and then we're going to go ahead and train our custom model, and then we can run inference against the custom trained model on live production data. So maybe you've got a conveyor belt and you've got a camera that's set up that's looking at that conveyor belt, or maybe even cameras on both different sides so that you can see both sides of whatever objects are passing through your conveyor pipeline. And as those cameras are taking images, they're just sending them to the Lookout for Vision service and running inference to either detect an anomaly or detect a normal object. So that's ultimately what our objective here is: to gather our data set, organize the data set, get it uploaded into Amazon S3. We create a custom model. We train it based on our input training data, and it gets tested against our test data set. So we're going to have kind of two different data sets: our training data set and our test data set, which need to be separate. We don't want to use the same image files for testing that we've already trained it on, because that's going to give you kind of inconsistent or unexpected outputs because you've already trained it to recognize those test images. And then we're going to talk about how to actually deploy the model and run inference against it. So, for starters here, you're going to want to have an AWS account, right? So, I'm already logged into an AWS account right here, and I've got the Lookout for Vision service. You can just go up to the unified search box here and search for Vision, and you should see that Lookout for Vision service. Do keep in mind that this service is only available in certain regions. So, if you click on the region drop down here, you can see that a lot of regions are actually grayed out, like Northern California, Mumbai, Osaka, Singapore, Sydney, and a bunch of others are grayed out as well. So you're going to want to make sure that you choose a region that is supported by this particular service. Now, the Lookout for Vision service does require that we upload our data into an S3 bucket. There is actually a way to upload directly from your computer as well, but generally speaking, if you're working with large amounts of data, it's a good idea to go ahead and upload it into S3. So as you can see right here, under the first time setup, it says, okay, you're going to need to create an S3 bucket in this particular region, and that's going to allow us to utilize this service. So we're going to go ahead and create an S3 bucket for starters. And we're also going to be referring to the Lookout docs. So let's search for Lookout Vision docs right here and pull up the AWS documentation for this service. We're going to go into the developer guide here, and this talks all about how to kind of set up your service here, how to set up your AWS account, how to set up your S3 bucket permissions and things like that. And then we're going to go ahead and actually train the model. So we're going to create a model, we're going to train it on our custom data set and all that fun stuff. I've actually got an Android device right here. Of course, you can use an iPhone as well if you'd like to, or even just a regular camera, but I'm going to be using my Android device here. It's a Google Pixel 7 Pro, and we're going to be using this to actually gather images of our two different boxes right here so that we can take a training data set and a test data set for anomalies and a training and a test data set for normal boxes as well. So for starters right here, what we're going to do is create an Amazon S3 bucket. So let's head back over to our AWS account right here. We're going to search for the S3 service right here, and we're just going to create a bucket for us to upload our data inside of. So I'm going to go here and just say create a new bucket. We'll choose the US West to Oregon region right here, and we're just going to call it something like Stratus Grid USW2 Vision test. And we're going to go ahead and enable bucket versioning as well. So later on, when you start working with the Amazon Lookout for Vision service and you want to do some additional training on that, it's called a trial detection feature. You need to make sure that bucket versioning is enabled. Otherwise, you'll get an error and you'll have to go switch on versioning at that point. So just make sure you enable that at the beginning right here. So I'm just going to choose to create this bucket right here. And then what we're going to do is head back and actually create some data to upload into that bucket. So I'm going to search for Stratus Grid right here, and we're going to open up this bucket right here. Right now, we don't have any objects in this bucket, but what we're going to do is actually capture our data using our camera right here, and then we're going to upload all that data from our local system once it's organized into the correct data structure, and then we're just going to take those folders and upload them into this directory here, or into this S3 bucket, I should say. So the first thing we want to do is to actually capture our data set. And so I'm going to switch over to my little window here where I'm capturing my screen from my Google Pixel 7 Pro. And we want to go ahead and take some different images of these boxes that we have right here. So as you can see right here, I've got this app called F-Droid, and F-Droid is kind of an alternative marketplace to the Google Play Store. So a lot of apps you can install from the Google Play Store, but if there's certain apps that maybe are not allowed on the Google Play Store for whatever compliance reason, then you can actually just install this app called F-Droid, and it's a separate app, it's a separate marketplace, but once you've got the F-Droid app installed, you can just search for apps like the Open Camera app. So if I scroll down a little bit in the search here, you can see we've got this app called Open Camera, and this is the app that I like to use to capture images for these types of purposes. And then we're going to upload this data up to our computer here, organize it into the correct structure, and then we'll upload it into our S3 bucket. So the first thing I'm going to do is open up the Open Camera app, and as you can see, I've got my desk right here. And I'm just going to go ahead and take some different images of these normal as well as anomalous boxes right here, right? Now, one of the things I want to do is to make sure that my image files are in compliance with the requirements of the Lookout for Vision service. So if we check out the documentation over here for the Lookout for Vision service and go down to the quotas section right here, it actually tells you what image file formats are supported. So you can't use raw bitmaps, you have to use a PNG or JPEG. Also, the minimum dimensions are 64 by 64, the maximum size are 4096 by 4096. So one of the cool things about using this app here called Open Camera is that if I click on these triple dots right up here, I can change the camera resolution and I can just kind of cycle through your different resolutions right here and choose one. But there's actually a square resolution that's supported here called 1920 by 1920. So that's a square dimension where we have a height and width that are equal to each other. And then we also know that 1920 is larger than 64 by 64 and less than 4096 by 4096. So that's a good resolution to use from the Open Camera app. And when we use Open Camera, it's just going to store all those files locally. By default, they're not going to get synchronized to Google Photos or anything like that. So what we're going to do for starters here is just make sure that we have a diverse data set. So we want to capture these anomalies in different lighting situations, different angles, different, all sorts of different, parameters, right? So what I'm going to do for starters here is just start by taking photos of some of these different features, these anomalous features on the box right here. So I'm just going to take some images here, and you can see I'm going to kind of pan the camera down a little bit here. And it's okay if you get a little bit of background in there as well. It doesn't have to be exclusively of the box, but we're just going to start taking some images from, different angles right here. Let me actually just switch over right here so you can see what I'm doing. Same thing with some of these other features right here. We're just going to kind of go ahead and, take different angles, make sure we get some multiple features in there. In some cases, we might not have multiple features. We might just have one feature that is visible, like that right here. Sometimes images might not be totally in focus either. So if they are a little bit out of focus, that's totally fine as well. That just adds more diversity to your data set and helps to train the model a little bit better. So we're just going to keep taking some images here. We're going to, not worry too much about the background there. We're just going to maybe include some of these features together right here. And we're going to capture about 20 images or so, maybe 30 images, because one of the requirements in here is that you have to have at least 10 images. So where you have a separate training and a separate test data set, you have to train it on at least 10 images. So we want to make sure that we have plenty of images so that we can split all of our images, like let's say 30 images, into 15 for training, 15 for test on anomaly. And then for good, we also want to have 15 for test, 15 for training as well. So that's why I am taking so many different photos here from different angles and different configurations, right? So once we've got some decent data here, we also want to go ahead and take images of the good box here as well. So we're going to go ahead and take images here of our good box. This is going to look a lot less interesting because we don't really have as many features right here. But, you can see we have this little crease right here. We may not really care about that so much. So we're going to include that in our normal or good data set. I'm just going to keep taking some images here, maybe get a little bit of background in there as well. Keep taking some pictures. More over here. Kind of go up the side of the box right here. All right. My phone memory is starting to slow down a little bit just because I'm taking so many pictures. But as you can see, we've got a pretty good data set right here. I think if we just take a few more, we should be good to go right here. I'm going to include some more with some of the background just so that we can train on that additional background as well and make sure it doesn't try to include that background like the keyboard there or the mouse as being part of the anomaly, right? We want it to really focus in on having the these types of anomalies where we've got actual punctures and scratches being our box anomalies. And of course, depending on what type of product it is that you are attempting to do classification on or anomaly detection on, it's really going to kind of depend on different angles that you want to take and different types of defects that you're going to want to identify. But in this case, we just have scratches and punctures, and we've got our normal box. All right, so now that we've got the data gathered on our phone right here, the next thing that I want to do is actually upload the data from my phone to my computer. Now, there's a really cool service. It's actually an open source service called ShareDrop.io. I believe this is something you can actually self-host on your own infrastructure. But all you could do is go to sharedrop.io, and then you can click on the little plus sign right up here to pair another device with your computer as long as they're on the same network. So what we're going to do is open up our phone here. So we've got our computer that is already joined here. And so now we want to take this QR code, and on our phone, right down here on the Google app, you can see I can search by camera. And so what I'm going to do is just do a search with your camera, capture that QR code there, and then we'll just tap on that link to go to ShareDrop. And so now I can see my device. My local device is called Persistent Rhino, and the computer is called Enthusiastic Dog. On the computer over here, we'll just close that screen. And so now what I want to do on the phone is to click on Enthusiastic Dog, because that is the computer that I want to send files to. And then I can choose the media picker right down here. And now I can select a list of all the files that I just took here and then send them to the computer as a bundle, as a zip bundle. And then we can extract that bundle, we can organize the photos and cut them out into training and test data sets, right? So what I'm going to do is just select all these images that we took right here from this list. Just going to take me a minute to kind of go through this entire list right here. So let's just check all these images. And I'm just trying to keep a rough count here to make sure that I've got plenty of images. I think we are doing quite well here as far as how many images we have. We're going into the anomalies here now. We're going to keep choosing some more of these photos here. And as soon as I get to the bottom, we'll go ahead and stop and then upload those to my computer. All right, so I think we're going to include that one as well. We've got 61 files, so if we divide that up approximately by 4s, we'll have about 15 for anomaly, 15 for normal, for both training as well as test, roughly. So I'm going to select all those, and it's going to go ahead and bundle those files on my device right here. And then as soon as the bundling process is completed, it's going to go ahead and send that entire zip archive. So it's going to say, are you sure you want to send this zip file? We'll say send. And then on the computer, it's going to say, hey, somebody sent you a file. Do you want to save it? So we'll say, yes, we want to save it. We'll just transfer that entire zip archive with all 61 images over to our computer. And so now we are done with ShareDrop because we have a local zip file here. So I'm just going to go ahead and extract that to a folder really quick, and then I'll open up that folder right here. And so now what we want to do is kind of organize things inside of this folder. And what we're going to do is, according to the data set right here, what we want to do is customize our data set so that it has this kind of structure here. So we're going to create a train folder and have anomaly and normal. And then we're also going to have a test set as well. So we're going to have not only train, but we're also going to have test under our directory here. So let's start by creating a training and a test directory here. And then under each of those, we're going to do normal, and we're going to say anomaly as well. I'll go ahead and copy those empty directories and put them under the test directory here as well. So now we've got this folder structure entirely sorted out. So now what we need to do is take these image files and actually categorize them into each of those folders. So I'm going to grab a few of these scratches here and maybe some of these puncture wounds here as well. Looks like I've got 11 items selected. I'll choose a couple more of these scratches right here, and I'm going to go ahead and cut those and put them into my training data set right here. We'll go under anomaly because those are anomalies that we want to catch. And then if we come back to the top here, I'm going to go ahead and grab a bunch of good images here, or normal images. Let's see how many total we have. We have about 30. So I'm going to go ahead and grab 15 of those. We'll cut those and put them under train normal. So now we've got normal. We've got anomaly for our training data set. Now I want to do the same thing for my test data set. So I'm going to grab 18 images for anomaly, go under test, and upload those there. And then we're also going to take these normal or good photos and put them under test normal. All right, so now that we've got this data set up, what we need to do is upload this data into the Amazon S3 service. This is really easy to do because all we need to do is take the test and train folders and upload them into S3, and then we'll be able to use these S3 URLs to actually point the Lookout for Vision service at those S3 bucket locations for each of those data sets. So what we're going to do here is go into the S3 bucket in the S3 console. We're going to go to upload, and then we're going to say, I want to add a couple of folders right here. So we'll say add folder. Then we'll go ahead and say train right here. And we'll say add folder. Try that again. Say upload train. Say upload. And then what we want to see here is this folder structure where it's train/normal. And then if we go over to the next page, we should see train/anomaly as well. So we want to make sure that we're maintaining that folder structure. So then we'll go to add folder again, and we'll go ahead and choose the test data set here as well. And we'll say, yes, we want to upload all those images. So now we should have test/normal, test/anomaly, and we should also have train normal and train anomaly as well. So there's 61 files here, 25.8 megabytes, and we're going to go ahead and just hit upload here to initiate the upload of this data. Now, this can be a little bit slow through the S3 management console here. For some reason, I seem to get limited generally around 50 kilobytes per second, even though my connection is maybe like 10 megabits, so it should be able to do a megabyte per second. So that's another reason that it's good to use slightly lower resolution photos. But the higher resolution photos you use, even though they're going to be larger image files, they are generally going to be better for training because your model is going to be able to notice or observe more detail about each of those images. So I'm going to go ahead and pause the video here really quick while we do the upload process here. And then once the uploading is complete, we'll go ahead and create our project inside of the Vision service. All right, so as you can see, we have finished successfully uploading our 61 image files, about 26 megabytes right here. And down here, it just gives us a list of all the files or objects that we've uploaded into S3 and what the prefix or folder, so to speak, is that it exists inside of. So now we are ready to head over to the Lookout for Vision service. So let's head over there, make sure we're in the same region as where our S3 bucket is located. Let's actually double check that our S3 bucket is in the correct region. So I'm going to go back to S3 right here and just double check the region here. So let's go to buckets, and then we'll do Stratus grid and look for our vision test. So yeah, it's in US West 2. You can always go check in the console right here to make sure it's in the correct location. All right, so let's head back over to vision here. And we're going to go down to projects, and we're going to go ahead and say that we want to create a project. And it looks like it wants us to create this Lookout Vision right here. So we're going to go ahead and just create that. I haven't used it in this region previously. So now what we're going to do is create a new project. I'm going to call this Stratus Grid Dash Boxes. And then we'll click on the little Create Project button right here. And then what we want to do for starters is to define what our data set is. Now, when we click on the datasets link right here in the console, it's going to give us a couple of different options. Number one, you can start with a singular data set, and this will allow you to just kind of train on a minimal amount of data. But in this particular case, we actually built a separate training and test data set. So we're going to go ahead and choose that option. And then down here under our training data set details, we do have the ability, if we want to upload it directly from our computer, but we're going to choose this option from S3, which is a lot more scalable since we could do hundreds of images if we want to, whereas if we upload from our local computer, we are just limited to 30 at a time. So we're going to choose to import from S3 right here, and then down here, we're going to specify our S3 URI for our training set. So keep in mind that this entire box right here is for training data, not our test data. We actually have a separate section down here for our test data set. So what we're going to do right here is say S3 Stratus Grid dash USW2 dash test dash vision. I think that's what our name is. Let me go double check that over in the S3 console right here. So let's do a search for Stratus Grid and find our USW vision. So it's vision dash test actually. So let's do vision dash test, and then we're going to say slash training and then put a forward slash at the end. If you don't include a forward slash at the end, you'll get a validation issue right here. So make sure that you plug in that forward slash at the very end. All right, so now we're going to check this box that says automatically attach labels based on the folder name. So because we've already gone through and specified an anomaly folder and a normal folder, we know that those labels are automatically going to get attached as long as we check this box right here. Same thing for the test data set. I'm going to go ahead and copy this S3 URI. We're going to say import from S3, and we're going to change the training to test instead. And then once again, we're going to say automatically attach because we've already organized the test folder into normal and anomaly. So now we're going to click on create dataset down here at the bottom. And as you can see, it looks like that is not finding that particular prefix. So let's see what's going on there. I think the reason that's happening is actually because we did /train instead. So let's do /train here and then click on create data set again. And I think this time it's actually going to work because we specified the correct prefix. So as you can see, it says created training data set. And so now we're going to go back over into the data set section right here. And it's going to redirect us to our data set. And sure enough, under training, we have 28 image files, and under test, we have 33 image files. And each of these images has already been annotated with whether it's a normal or an anomaly. So we can filter the data set here if there's any unlabeled images for any reason. If in the future we import additional image files and they are unlabeled, we can filter by that. But everything already has labels because we did the configuration of our data structure before we uploaded into S3. So now what we need to do is to actually train a model based on this data set that we've created. So this is really, really easy to do. All we do is go up here and say train model. You can see we've got 61 image files in our source S3 bucket. And all we need to do is click on the button that says train model right down here, and then click on train model in that modal dialog. And that's going to kick off the training process, again, based off of our training and our test data set. So at this point, we can kind of pause and take a break because the training process can take anywhere from maybe a half hour to maybe a bit more than that. When I've been working with relatively small data sets, like 60 or 70 images or so, I've found that the training process takes about a half hour to complete. So we're going to let that go ahead and run, and then we'll come back later on and actually take a look at the trained model and how we can do something known as trial detection. So trial detections are going to allow us to take even more data. So we'll go ahead and capture more data. We'll upload that. We'll run trial detections against that, and then we'll see if the model that we've trained actually correctly detects those images as the correct classification, either normal or anomaly. All right, so now we can see that the training of our custom model has completed in the Lookout for Vision service. So what can we do with this model at this point? Well, if we select the model right here, we can see the metrics around its training, and we can see how accurate it was during the training and testing processes here, and we can see the confidence scores of each of these images. So right up here, we have kind of a relatively low confidence score, but it did get it correct that it's a normal box right here. Right here, we can see that this is an anomaly with a 91% confidence score. So we can kind of see how the model is performing right here. Now, one of the things that we can do is to go ahead and actually deploy this model by choosing the integrate with cloud option right here. And what this is going to do is generate some AWS CLI commands that we can use to actually start up an inference endpoint and basically make the model available for running classification tasks against it. So if you want to start the model, you can use this AWS CLI command right here and then run detections against it by using the detect anomalies API call here, which can be used from the AWS CLI or any of the supported SDKs for Python or Golang or Rust or PowerShell or any of the other SDKs that are supported by AWS. But this example right here just shows how to call the detect anomalies command in the AWS CLI. Now, one of the things that we probably want to do here is to run a trial detection. So with the trial detection, what we can do is take some additional images, kind of like what we did before, upload those to our system here, and then do a detection and see if those new images are correctly detected or not correctly detected. So what we're going to do is actually switch back over to my phone right here, and we're going to just take some additional images, right? So this is kind of like taking a third data set, if you will. So we took our training, our tests data, and now we're going to take some new data to run through the trial detection. So I'm going to open my Open Camera app right here, and I'm going to take a few anomaly photos. So let's take, maybe one here, two, three, four, and five. And then I'm also going to take some additional normal photos here as well. So I'm going to do maybe one, let me do one, two, three, four, and five. Maybe I'll do six, seven, just to take a few there, right? All right, so now that we've got these additional images, we want to go ahead and upload those again. So what we're going to do is go to the ShareDrop website here, sharedrop.io, and then we're going to go ahead and join a new device here. So we're going to go ahead and choose the lens icon here on our mobile device, and we're going to say search with camera. And we're going to go ahead and find that QR code and then just click on the link for it, take us over to ShareDrop. And now our local device right here is called Compassionate Monkey and the computer is Sincere Chicken. So I'm going to click on Sincere Chicken from the mobile device, go to my media picker right here. Again, it's going to be a little bit different with iOS. And then we're going to choose all of these images that we just took within the last couple of minutes here. So we'll select all of those images. It'll bundle them up once again. We'll say send from the mobile device. And then back on my computer, we'll go ahead and save that new data set. And now I'm just going to go ahead and extract it in another window right here, and then bring that onto the other screen. So now these are all of the images that we're going to do the trial detection against. So we're expecting that our trained model is going to correctly identify all of these images. However, if any of these images are incorrectly classified, we actually have the ability to specify that the model was incorrect, and then that will kind of fix the label classification that's being designated for each one of those images. So what we're going to do is come back to our lookout for vision service right here. We're going to say, I want to run a trial detection here. And then I'm going to call this, Stratus Grid trial 01. You can give the trial whatever name you want to. Of course, we only have one model version here, so I'm just going to choose the current model version. But if we had multiple trained model versions, you could just select the latest one or whichever one you want to kind of build on top of. And then this time, I'm actually going to use upload images from your computer. We'll say detect anomalies, say run trial detection, and then we can drag and drop up to 30 image files. So I'm just going to do a Control A to select all these and then just drag these over to this drop point here. And so now we've got these 12 images. We'll say upload. All those images will get uploaded into the Lookout for Vision service, and then it's going to run inference against each one of those image files during the trial detection. And then at the end of that trial detection, we can validate either a correct classification or an incorrect classification, and then add all of this new data to our data set that we can then train another custom model on. So we're just going to give this a moment to do the anomaly detection or the inference against our trained model. And then at the bottom here, we're going to see a list of those images and the result or the classification, either normal or anomaly, and then have the chance to fix that. All right, so now our trial detection task has completed and anomaly detection has been executed against each of these images. Let's check out the results and see if they were accurately detected or not. So if we scroll down a little bit here, we have a list of all of our images. We can go ahead and click on Verify Machine Predictions, and that will unlock the buttons down here for us to specify whether the model was correct in classification or incorrect. So right down here, it says that this is normal. It only has a 38.6% confidence score, but it was actually correct. So we're going to say that that is correct. Right over here, this was predicted as an anomaly. And you can see very clearly that this is not actually an anomaly. So we're going to say that that is an incorrect detection. Same thing with this one here. This is predicted as an anomaly. and it has a pretty high confidence score. So we're going to say, no, that's actually not an anomaly. So down here, once again, we're going to say that that's incorrect. That's a perfect box there. Down here again, we're going to say that no, that's a perfect box. So we're going to say it's incorrect. This one here was predicted as an anomaly with 94.3%, and that is correct. So we're just going to hit the correct button right there. Down here, we've got anomaly. We'll say correct. And then twice more, we have anomaly correct, and anomaly is correct. After we have verified all of these results here, we can say, I want to add the verified items here to my training data set. So we'll hit add, and that will allow us to include these in our training set. There's actually a few more images here as well. So we've got the anomaly, that is correct. This was predicted as normal. That is correct as well. And this one was normal, and that is also correct. We'll go ahead and add those additional ones to our data set. So at this point, we have now customized, we've kind of tested out our model. We've determined that we have some anomalies that are incorrectly being detected. And so we've corrected those, and we've added all those files to our data set. And we can now train a new version of our model by coming back to our data set. So we'll go under data set right here, and we can just click on train model, and we can go ahead and then just specify that we want to start training a new model version. I'm going to go ahead and cancel that for now, but I just wanted to kind of show you how the trial detection feature works so that you can expand on your data set, train new model versions, and continue refining your models over time. But the last thing that I wanted to show you here is once we've got a trained model version, how do we actually go ahead and deploy it, right? Well, what we can do is just check off the model version that we want to deploy by clicking that radio button, go to Use Model, and say Integrate API to Cloud. Basically, all this does is it gives you the AWS CLI commands to start your model and then run anomaly detection against it. So what we're going to do is go ahead and start our model. I'll copy this command, and then I'm actually going to open up another service here called the Cloud Shell service, and this has the AWS CLI pre-installed. Plus, it uses the credentials that you're currently logged into the console with, so you don't have to set up any additional roles or users or anything like that in the IAM service. I'm going to go ahead and paste in this command right here and say, yeah, go ahead and paste that multi-line command. We'll hit enter here to start our model. And as you can see, the status is starting hosting. So once we've done that, we can go ahead and actually run inference against this endpoint. So what we're going to do is go back here and take a look at the detect anomalies command right here. And this is going to go into the Lookout Vision service called the detect anomalies API. And then we're going to specify the path to our image file that we want to run inference against. And we also specify the MIME type or the content type of that file. It could be image PNG or image JPEG. And all that's documented under the Lookout for Vision documentation. If you head down to detecting anomalies in an image here, it talks about the different input arguments that are required to call the detect anomalies API. You'll see that image/PNG or image/JPEG are supported values. And then with the AWS CLI in particular, the body is just going to be a path to the file because the AWS CLI knows how to read the file as a byte stream into the API and actually invoke it. So what we're going to do is come back to Cloud Shell right here, and we can go to Actions and say Upload File right here, and we can upload a file from our local system. So what I'm going to do once again is switch back to my Android phone here. We're going to go back to the Open Camera app, and I'm going to take a couple more pictures. We're going to take one here. That should clearly be an anomaly. Let's actually go to Open Camera app here. We'll take a picture of an anomaly, and we'll take a picture of a normal as well. And then we're going to go ahead and upload those. So once again, we're going to open up the ShareDrop website right here. We're going to add our device once again. So we're going to go to the device, click on the little camera icon in the Google app and say search with your camera. And then we're going to go ahead and scan that endpoint and click on it, load it up, click on Sincere Chicken, go to our media picker, and we're going to upload these two new images that we just took, say send, and then back on our computer, we're going to save those once again. And now I'm going to go ahead and just extract these into a new folder on my other screen here really quick. That'll just create a new directory with our image files here. And so now what we can do is upload these image files into our Cloud Shell server right here. So we'll say upload file, and then I want to specify this path right here. So we'll go into that folder, and we're going to go ahead and let's see if we can do a multi-select. It looks like we can only do one at a time. That one's going to end in 55. And then we'll do upload file again, and we'll specify the other file ending in 00. And then once those files are both uploaded, it looks like we've actually got an issue here with too many requests, so let's try that again. But once we've uploaded these files into the Cloud Shell server, we can go ahead and run the CLI command. So it looks like it's failing with the other file for some bizarre reason, but we'll go ahead and come back here. We'll copy this command right here, come back to Cloud Shell. We'll paste in this multi-line command. And what we're going to do is just change the path right here to the name of this file since we've already uploaded it to the server. So we'll just paste that in right there and say paste and hit enter to execute that command. And as you can see right here in the result that we get back from the inference API in the Lookout for Vision service, it has this detect anomaly result object. And then underneath of that, there is a confidence score of 94%, 94.2%. And it says is anomalous is true. And sure enough, that image that we took right here is definitely anomalous, right? Let me try one more time to upload this other file and see if it'll work this time, and then we can run inference against that as well. Looks like it is uploading just fine this time here, so we'll let that finish really quickly, and then we'll go ahead and run inference against that. So once again, I'm going to paste in the command down here, and I'm going to replace the file name with the other image file that we have that is normal. Go ahead and hit enter to execute that command. And as you can see, is anomalous is now set to false, and it has a pretty high confidence of 95%. So by the end of this video, you should be able to understand how to create your own custom project in the Lookout for Vision service, starting with gathering your data, structuring your data in the proper format so that you've got your training and your test data separately, as well as the normal and anomaly labels for that data. You should know how to train your custom model. You should know how to run a trial detection against that model to determine if it's functioning properly and expand on your core data set so that you can train more intelligent models in the future. And remember that even though we used these boxes in this particular example where we have anomalies on boxes, you can really use any type of picture that you want to on different types of objects, whether they're t-shirts or hats or any other type of manufactured product. If you need to detect maybe cracks in concrete, or if maybe you're shipping something like candles and you want to detect cracks in the candle housing or something like that, there's all sorts of different use cases for this computer vision task to do anomaly detection in short. So in any case, I hope you've enjoyed this video and learned something new about the Lookout for Vision service in Amazon Web Services. Again, we are Stratus Grid. You can go to stratusgrid.com, hit the Let's Talk button right up here, and get in touch with us, and we'd be happy to discuss your project needs with you. Thanks for watching, and we'll see you in the next video. Take care.